In this video, I'm going to go over PAT questions involving circle geometry. Okay, so what I've done is I have pulled PAT questions from 2010 all the way up to 2015, and like I said, they're all involving circle geometry. So what I recommend for this is to actually try and solve the problem on your own, and then go ahead and watch the video to see if you got the question correct or where you might need a little bit of extra practice. Okay, let's start off with this question here, number 38 from this PAT here. So a couple of things to notice here. The first thing is they gave us a tangent. Now remember, a tangent is a straight line, and because it's a straight line, it is actually going to have an angle of 180. So that means we can use that to figure out the angles of everything else. So if this whole portion is 180, meaning from here to here is 180, well, we can subtract our unknown angles to figure out the missing angle here. And oh, I'm so sorry, I'm jumping ahead. Let me read the question. So the question wants us to figure out the measure of this angle here, so that angle X. So we're gonna use that tangent along with our properties of triangles to figure out that unknown side. Sorry about that. So once I look at my 180, I can actually remove the 70 degrees that they gave us along with our 60 degrees that they gave us. Altogether, that's going to give me 50. So if that's 50, what that means is this angle inside here is going to be 50. Now we got to think back to our elementary math. So one of the things that we know is all triangles have angles that add up to 180. So if that's the case, we're then going to need to take up all our angles here of 180 and remove our known parts to figure out the value of X. So we're gonna have to go 180, take away the 60 that they gave us and the 50 that we just found out. So that's gonna leave us with angle X is going to equal 70. So therefore, our answer is going to be D. So I just wanted to let you know that in the description below, I do have a set of guided notes that you can download. What is unique about these notes is there is a QR code that you can scan to get a video explanation of the laws that you need to know. Okay, this is numerical response number 2 from the 2010 PAT, so a little bit old, but still a good question. So let's go ahead and read it this time. The diagram below shows a circular pipe that has O as its center. So that's just like the central point. The radius of the pipe is 20 centimeters, okay? So they've given us a really good diagram here, which I like. And from there, our job is to figure out the maximum depth of the water in the pipe. So that part is going to be crucial. We want to make sure we're getting the maximum depth. So let's break down the diagram a little bit. Here's our circular pipe. So when we think about this, most pipes are circular. In fact, you all let me know if I'm wrong. I think all pipes are actually circles. And what we've done is we've cut it. So we're given this diagram here. Now this is the portion that's filled with water, and they want to know the maximum depth. So the maximum depth is going to be from the center to the very bottom of the circle, because that's the most amount of water it can hold at this level here. Now we do know our radius, as we said before, is 20 degrees, and we know they gave us this line here. So do we remember what that line is called? Okay, I'm hoping you said it. That line is a chord. So that means it's a line, a measurement from edge to edge of the circle, and that is 32 degrees. And as we cut it here to find the maximum angle of the maximum distance of the water level, we are cutting it at a right angle. Now remember, this comes from that law that says anytime you have a chord and you cut it vertically, it's going to be a perpendicular bisector, meaning we can make a right angle. So right angles are important, and the PAT is famous for these kind of questions, where what they are trying to get us to do is to create a right angle triangle. This allows us to utilize our scales from last year, which we may have forgotten, but I'll go over it with you today. So let's try and think about this. So we've got our radius, and this radius is from the center of the circle to the edge of the circle. That means no matter where I go, from the center to the edge of the circle, I can always have that radius of 20. So I can move it here, 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 just like those arms of the clock, and it will always be 20. That's really important to remember. So now when we're looking at this, we can start to say, well, how can I move that radius to possibly get a right angle triangle, given the fact that we know when we cut a chord right here, we get a right angle, okay? So one of the things that we can do is rotate it just so it makes a triangle. So I'm gonna rotate it right here, and it doesn't matter which side you rotate it, I'm just gonna do it this way. So this allows my radius to go from the center to the edge of the circle, okay? And then we've got the base of the triangle coming from that chord of 32 centimeters. Then I can draw my perpendicular bisector right here. Okay, that's looking a lot better. It's looking a lot more like a triangle. So now we can put the dimensions on it. So we know the hypotenuse, the long side of that triangle, that's going to be 20 centimeters because that's the same as the radius. And we know the height of it, well, that's what we need to figure out. That's our unknown. And then the bottom of it, well, we have to do a little bit of thinking here. This whole chord is 32, but we've created a perpendicular bisector where we're splitting that chord in half. So you guessed it, that means this bottom part is going to be 16. Now we have a right angle triangle, and we can use our Pythagorean theorem to figure this out. So that will leave us with the following. We're going to get 16 at the bottom, our unknown here, and our hypotenuse of 20. So we know a squared plus b squared equals c squared, and we can fill in our portions. So a and c are interchangeable. Our c is always going to be that hypotenuse, okay? So that leaves us with and then now I can start to solve it. So 16 times 16 is 256. B squared is going to stay b squared, and c squared is 20 squared, which is 400. Now we want to solve for b, so we're going to take away 256 from both sides. That leaves me with b squared is equal to 144. This is beautiful, it's a perfect square. So the square root of 144, and sorry, we're taking the square root of both sides to get b alone. Just as a remember, if we forgot, what this is saying is a number times a number. The same number gives us this value here. So in this case, we're saying b times b gives us 144. So what is b on its own? We got to do the opposite of squaring, which is the square root. And that's going to get us to become b equals 12. Now, here's the tricky part. I know a lot of you are tempted to say, okay, we're done. Ms. Mahal, we're done. We're going to put that 12 there. That is not the case, okay? Let's go back to our question that I highlighted in that bold pink. We want to know the maximum depth of the water pipe. We've only recently just figured out that this is 12. That is the height from here to here, not the maximum water depth. So we got to think, how do we figure out this portion? That's the only portion we want to know, given that we know from here to here is 12. Okay, so if you're thinking about it, hopefully you're thinking that we can use our radius. So our radius, again, we can draw it out anywhere over on the circle, which means our radius is going to be here. That whole portion is 20. Now, since we only want to know the depth of the water, we can go ahead and take away our radius. We can go 20, take away the portion that we found out, which is 12, and that's going to give us a maximum depth of 8 centimeters. So the answer for this one is 8. Okay, let's look at this example here, numerical response number 5. So this is one of the ones that we really need to be clear about those rules for circle geometry, okay? Otherwise you might look at this and be like, what's going on? So let's take a look at the question. If O is the center of the circle, the measurement of X is blank. So not a whole lot of information. We have our circle. We know the measurement of the circle at the center is 70. And then we're trying to figure out X. So if you don't know the rule for this one, it is going to be a little bit tricky. So the rule for this one is we have to recognize we have our central angle, which is 70. And then we have two chords that come together to make what's called an inscribed angle. So the rule of an inscribed angle is it is half the central angle. Or you can also say the opposite. You can say the central angle is double the inscribed angle. So then in this case, once you know the rule, it becomes a little bit easier. Well, if this angle is 70 and the inscribed angle is half, we have to find out what half of 70 is. Well, half of 70 is going to be 35. So that tells us that x is 35. Okay, number 12 here. So again, this is another one where we want to be clear about those rules that we're looking at. So we have a couple of things going on here. We do have, again, two chords coming together to make this shape. We have a central angle, which means then, as we noticed in the previous question, this would be an inscribed angle. And then we've got a straight line hitting the edge of a circle. So kind of like what we saw in our first question, this is going to be a tangent. All right, so now what we need to do is we need to identify all those portions in this multiple choice question here. So one thing I should mention, we do need to be careful and be aware of how to read geometry, if you will. So when they use this symbol, what they are saying is they're talking about the angle, specifically the angle that's in the letter of the middle, okay? So I'll show you what I mean. So they're saying angle ADB, which means they're looking at ADB. And the one that's in the middle of that, the only angle that's there, would be angle D. I know that's confusing, but that's what that would be, okay? And then when they're using this symbol here, they're saying the line AD, and remember that's just going to be referring to a chord. And then with this one, they're talking about that tangent, which is still a line. It's just a line that goes on forever, which is why they represent it with those arrows, okay? Hope that made sense. So let's go ahead and let's look at it. So as we identified at the start, this is an inscribed angle. That means in our options, we can cross off anything that's not an inscribed angle. So that means C and D we can cross off. We then can look at the next portion. Well, we've got line AD. Line AD starts at one end of the circle and ends at the other circle. It does not go past the circle. That means it's definitely going to be a chord, meaning we can probably cross off the tangent. And then we have another symbol here, so angle ACB. So we can look at it and go angle ACB. Okay, so that one is looking at really this portion here of the circle, which is right in the center. So that we know is going to be a central angle, which doesn't help us too much to eliminate options, but we know it's a central angle. And then our last one is EF. Well, EF, again, we're looking at those arrows, and as we identified at the start, that's a tangent. So therefore, our only option for this would be option B. So we've got question 10 here. Now, this one is a word problem. And again, with circle geometry with the word problem, we are kind of looking to see any patterns we notice or anything that comes with triangles or identifying some of those rules. So let's go ahead and let's read the question and identify the important information. The gong shown below is 30 centimeters in diameter and hangs by a chain from a nail. The total length of the chain is 18 centimeters. And this is important, the lengths of each side of the chain are equal. So that means where the nail is it's cutting it right in the middle. But this whole thing here is 18, okay? We also know that it forms a tangent. And that's important because we know when a tangent is hitting a circle, it does end up creating a right angle, if you were to cut it directly perpendicular on the tangent. Okay, so let's figure out what this question is asking us. How far above the top of the gong is the nail to the nearest centimeter? So what they're really asking in this question, which I can see why it might be complicated to some of us, they're asking the distance between here and here. Okay, now let's go back and let's think about what information we know. Well, we know the chains are of equal sides and we know the total length is 18. Well, that means this side has to be 9 centimeters and this side has to be 9 centimeters. So we've taken care of that. We also know that the radius is 30 centimeters. So that means if I were to draw a line here, the diameter is 30 centimeters. So that portion there is 30, which means our radius, which is half the diameter, is 15. Now, as I've said before, with those radius, it's from the center of the circle to the edge. but we can get really creative and rotate it anywhere around the circle, so long as it starts in the center and goes to the end of the circle, okay? So in this case, I'm thinking we have a tangent. It is going right across the edge of the gong. And we know with tangents, and as I said at the start with a circle, we can create a right angle. So that means I need to find a way to again, manipulate, move my radius anywhere on the gong to create probably another right angle triangle or a square, depending on kind of what works. So I'm gonna rotate it in the way where I can start to see a square form, or excuse me, a triangle form. So I'm gonna rotate it right about here to the center. And I'm gonna draw it as best as I can perpendicular. So as I start to draw that out, I can start to see I've got my right angle. We've got our tangent. I'm gonna draw it extended. We've got our tangent and we've drawn a line that cuts it perpendicular, right? So that means it's hitting it at a 90-degree angle. Sorry, a 90-degree angle. There we go, a 90-degree angle. And that's something that we can use going back to Pythagorean theorem. So I personally don't like seeing the triangle like this. It's kind of confusing. And remember, when you're doing your PAT, you can write all over it. So I'm gonna draw the triangle out over here in just a way that makes more sense to me. Okay, there's our triangle, and I'm gonna transfer my numbers over. And then if we're not sure, we've gotta just think that radius came from the diameter. Half the diameter becomes our radius. So in this part here, it is going to be 15 centimeters. All right, now we can use Pythagorean theorem just like in that previous question. I will write out everything for you. Now remember, A and B can be switched out interchangeably. And our hypotenuse, the side on the diagonal, will always be C. We can't switch those ones around. So I just got 306 by squaring these and adding those together. And that's gonna give me with C squared. We then can take the square root of it, and you'd have your calculator to take the square root of it. So C is equal to 17.49 centimeters. Now let's go back and apply it to this question, okay? We know this value here is this, but on our gong and the nail above the gong, that is just this value here. But the question asked, we need to find out this portion here. So if we have the total length of the hypotenuse, or this line here, how do we subtract the part from the gong to just get the part that we need to find out? Hoping you said radius. That means we can take away our 15 centimeters, and that's again coming from the radius, and that's gonna leave us with 2.49 centimeters. So let's go ahead and look at our options. So we're gonna round to the nearest tenth. This 9 is gonna tell that 4 to go up. That gets us to 2.5 as our answer. Okay, so I had some technical difficulties, so I've just refilmed this question here. So let's go ahead and read it. So here we have a diagram of a swimming pool is shown below. The dotted circle represents the floating buoys. The pool has a diameter of 10 meters. So what it is here's our pool, and we've got the buoys just floating in there, creating a circle. Now our job is to figure out the shortest distance from the buoy to the edge of the pool. So that means really what they're asking us is they're asking us to figure out the shortest distance, which is gonna be right here. That's our shortest distance from the buoys to the edge of the pool. Now what we need to do is we are gonna need to figure out a couple of things with regards to our radius and regards to making, again, a right angle triangle. So let's take a look at what we know. We know the pool has a diameter of 10 meters. So again, what that means is if I were to draw a straight line here, cutting that circle in half, that's gonna give me my diameter of 10 meters. Now, again, we have to be really mindful and think about how can we move that diameter, or in this case, actually the radius, to create a right angle triangle. So again, I'm just gonna go ahead and kind of play around with it, move it like the arms of a clock, and see where I can get a triangle. So one of the things that I'm noticing is, again, we have a chord and we're cutting it in the middle, so that's going to create our perpendicular bisector. In fact, I'm actually just going to draw that one in for us. Sorry, that would be right there. And then if I were to move that radius, so I'm actually going to get rid of the line that I drew as the diameter and draw just the radius. I can start to draw it from this corner to the center of the circle. So once again, I'm going to get a right angle triangle. So by now you probably know I'm going to go ahead and redraw it. So that means the base of this triangle is going to be right here. Well, that's actually kind of what we need to calculate. So I'm going to say that that's our unknown. We know that if the chord here is 6, then we will use half of it to give us the height of the triangle. That will be 3. And our hypotenuse actually comes from the diameter. And because the hypotenuse is the radius, we know that that's going to be 5. So now we can do our same thing using our Pythagorean theorem. So that's going to be a squared plus 9 is equal to 25. I want to get a squared alone. And then to get a alone, I'm just going to do the opposite of squaring it, which is taking the square root. That's going to leave me with 4. So again, we have to be clear. This 4 really just represents here. We know that the length of the center of the circle to the buoy is 4, but we want to know the shortest distance. That means we're going to have to take our whole radius. So that means our radius is 5, and we're going to have to take away the 4 that we just figured out. That leaves us with a 1 meter for the leftover portion that we're trying to figure out. So our answer for this one is going to be A. Okay, number 26 here. So this is again another one where we need to be really clear about the rules, which is probably true for all circle geometry questions. But let's see what we've got going on. We have our letter O, which is our center, our central angle really, and they told us our central angle is X. We also know we have a tangent that cuts across the edge of the circle, and the distance between here to here, or the angle between the tangent and the triangle in the middle, is 65 degrees. Our job is to figure out the measure of angle X. So again, this is another one where they give you very little information, but it's your job to know the rules and figure out how those rules apply. So let's look at our 2 factors here. We know with the tangent that this angle we know that the angle of the tangent is 180. Okay, now that's helpful, except we don't actually have another piece here to subtract the 65 from. So one of the things that we do notice, or hopefully you've noticed by now, is that this is an isosceles triangle. So an isosceles triangle means that 2 sides of the triangle are the exact same angle. Okay, now the other part of that is if I were to cut the tangent right in the middle, as we can see that triangle is doing, it's creating another perpendicular bisector. So a perpendicular bisector means that when we cut it against a tangent, we're going to get our 90 degrees. It's how we've been able to get those triangles in those previous questions. So now what we can say is here to here is 90, but we have that 65. So now we can say, well, okay, if that right angle triangle is 90, we can go 90, take away our 65, and that's gonna get us 25 degrees. So that means this portion here of the triangle is actually 25 degrees. Now, as I said before, it's an isosceles, so that means this also has to be 25 degrees Celsius. Now, we know with a triangle, all the angles add up to 180, so we essentially can go 180, take away our 25 from the corner where the tangent is, plus the 25 at the top, so really we're taking away 50, that's gonna leave me with the remaining of 130. That means angle X is going to be 130. So our answer to this question is C. Okay, here is number 8 from the 2015 PAT. It's another word problem 1 where they've given us a diagram. Now I do want to just add that there are 2 ways to solve this question. I'll just go over one, but feel free to play around and see if you get the other way to solve it, and of course the answer is going to be the same. So let's go ahead and read our question. So the arch in the diagram below forms a complete half circle. The black support beam in the diagram is 3.6 meters in length, and 3 meters above the surface of the water. We need to calculate to the nearest meter the diameter of the arch. So a couple of key pieces of information here. We know it's a semicircle, so that means whatever we get for the diameter, we're going to cut that right in half of the whole circle. The second thing we know is that the length between the black bar to the center is 3 meters. So I've taken care of that, and they said the black support beam, which really just acts as another cord, is 3.6 meters. All right, so I think we're missing one piece of information. Sorry, give me a quick second here. Okay, sorry, so now we need to figure out the diameter of the circle, meaning what they're asking us to do is they want us to figure out really this portion of that water. That's what they want to know, because we know it's a full circle. If it was a full circle, the diameter would be cut right in the middle. I actually think it's a little bit of an oval, but we'll go with it. And if we can figure out the length of that water, this portion here, then we can figure out the diameter. So now we're looking at this. We've got a chord, and we have, you guessed it, a perpendicular bisector. So that means we definitely can start to move our radius and try and get a right angle triangle. So if this is the diameter, half the diameter is the radius, meaning the radius is from here to here. Now, as I've said in this whole video, we can move that radius however we want. We can move it here, here. Well, really that would work, because that is going to get us our triangle, our right angle triangle. So I'm going to go ahead and draw that in. Now in this case, we don't actually know the radius. That's what we're trying to figure out, because if we get the radius, if we get x and we double it, then we get our diameter. So that means we can use our same Pythagorean theorem. And in this case, we're trying to figure out c squared. So we have a squared. I'm just going to say a squared is that vertical line of 3. However, we may be tempted to write 3.6 for the whole portion here. But remember, we're cutting this in half. It's a perpendicular bisector. So that means we have to go half of 3.6. So I just think of that as 36. Half of 36 is 18. So I can pop that decimal in, get 18 squared. Add those together after I square it. That's going to get me 12.24 is equal to c squared. To get c alone, we're going to go and take the square root of c, or 12.24. So c is equal to 3.5 meters. Now watch this carefully. In this test, they've made the 3.5 meters, excuse me, I can't get my units right today. They've made that option A, and they do that for a reason. Because what they're thinking is you're going to forget. Your job is to figure out the diameter and not double it. And then you're going to select A, but of course we know that that would be incorrect. So let's double our 3.5. Double 3.5 is going to give me 7 meters. So this is really the 3.5, and that's the 3.5. Combine that together is 7. So our answer is going to be C. Okay, I've got number 11 here. It's a multiple choice test question. So what we're saying is the letter W is the center of the diagram of a house, or of the diagram below, excuse me. And we can see that that's going to be right in the center of a circle. It represents the location of the wireless router for the internet access in a square house. So we've got a square and a circle. We know that the router provides access to the area represented by the dotted circle in the diagram below. So what we're saying is here's the apartment complex, whatever you have it as, here's the internet, but here's where the Wi-Fi can travel. Okay, so we can go outside the house, which we know, right? If we're outside our homes, we can still probably connect to our internet within a certain distance. We know that the circular area has a diameter of 20. So that's important, and you know what I'm going to do by now. I'm going to go ahead and draw that in just so I don't forget. Okay, so our job in this question is we want to figure out to the nearest of a meter the distance from the router to the middle of one of the outside walls. Okay, so you're thinking, well, what does that mean? Well, let's think. We want it to the middle of one of the walls. So if that's the case, to the middle of the outside wall, excuse me. So if that's the case, then what we're going to really want is we're going to want to figure out just a corner there. We want to know that distance. And that's because, like we said, if the internet is traveling like this, we basically want to know in the home what's the furthest it has to go. We're not too worried about here because we're outside the home. Okay, so let's look at kind of what's happening. Again, we've got a square. That means with our squares, we have portions of it that are going to be right angle triangles. We also know with our radius, when we cut that diameter in half, we can, you guessed it, move it anywhere across the room that would make sense. So one of the things that I can see right off the bat is if I were to move that radius right here to that corner, I am going to get, you guessed it, a right angle triangle. Now this was a little bit different than previous times because what's happened is it's a square. Now we know with squares that means every side is the same length. So that means that if this portion is x, well, it also means that this is x. And this is going to change a little bit on how we do our Pythagorean theorem, just a little bit. So I'm going to write our formula as always. And we're looking at the triangle. So the hypotenuse is really what we want to figure out. That's our distance. So c squared is just going to stay c squared. But a squared and b squared are actually going to be x and x. So this question is quite interesting because it pulls on your knowledge of polynomials. So we're saying x squared plus x squared. So we have two like terms and we're not multiplying them, we're adding them. We basically have two of them. So that's going to leave us with 2x squared, which ends up being the same as multiplying. I apologize for saying that. So now we have 2x squared is equal to c squared. Now c squared I made a mistake here. C squared we do know because that is the radius and that's going to be our 10 centimeters squared. 10 meters squared, which means that's going to be 100. Okay, let me just recap in case that was confusing. So we're looking at our triangle here and we're saying the base of the triangle and the height of the triangle, or A and B using Pythagorean theorem, are both x's. Because it's a square, they have to be the same length. We know the hypotenuse of the triangle because that is coming from our radius, which we know is 10 centimeters, half the diameter. So now we can put this together as x squared plus x squared, which is 2x squared equals 100. Okay, now we want to solve for x. So we're going to divide both sides by 2, which gets me to x squared equals 50. We then want to get x alone, so we're going to square root 50. And that leaves me with, and yes, you can use your calculator for this one, leaves me with 7.07 meters. So the distance that we can use for this one is 7.1 once we round it out. So it's going to be option A. Okay, last question here. This is number 27. And so what we want to do is we've got point O in the center of the circle, and we want to figure out the value of x. So a couple of things that are probably coming to mind at this point. We know we have our central angle. We've got part of it anyway, and we've got our inscribed angle. So remember our central angle, whatever this whole angle is, let me zoom in so you can see that. Whatever our whole angle is, when we cut that in half, that's going to give us our inscribed angle, which is what we want to find out, right? We want to find the value of x. So what's tricky about this one is they have only given us a portion of that central angle. We need to figure out the rest. So let's see what we've got here. We have a triangle. And then we need to carefully think, and I agree with some of you that might be thinking, what kind of triangle is this? Or how do I figure this out? So it's not the best diagram in my opinion, but if we look at it closely, we can see the bottom are the same size. So this is again an isosceles triangle, meaning this portion here has to also be 75 degrees. Okay, so if that's 75 degrees, we know all the angles in a triangle add up to 180. So we can use our 180, take away 75, plus 75. That's gonna get me to a total of 150. So now I can say, well, all the angles in the triangle, in this triangle here are 150, or excuse me, are 180, take away 150. That's gonna leave me with our missing portion of 30 degrees. So I can now that I have those pieces together, I can put them together as my central angle. So my central angle is 94 plus 30. That's gonna give me 124. So our answer isn't 124, but we can use that. That's the central angle. So once we take half of 124, I'm going to get 62. So that means this angle here is 62 degrees. So the answer for this one is B. So I hope that information helped you. I do hold one-on-one sessions. All of that information can be found down below. As I said before, the PATs are also found below, so you can follow through each one and practice on your own. Until then, good luck, and I'll see you all in the next video.